What if the most advanced AI supercomputers on the planet just became available to rent by the hour? This week, AWS opened the floodgates, unleashing Nvidia's latest silicon monsters onto the cloud, and it changes everything about how we build the future of artificial intelligence. For years, the cutting edge of AI training has relied on ever larger, ever more expensive hardware. Now, Amazon Web Services takes a giant leap forward. They are introducing their first UltraServer pre-configured supercomputers. These are not just any machines. We are talking about systems built around Nvidia's Grace CPUs and the powerful Blackwell B200 GPUs. They call these new offerings the UP6e instances, available in full and half-rack configurations. These new beasts complement the existing P6 B200 instances, which AWS unveiled back in December. Think of it like this: traditionally servers had separate brains and memory, but with these new systems, Nvidia uses something called NVLink 5. This technology allows them to gang up GPUs into massive shared memory compute complexes. Imagine a single enormous brain for your AI models, stretching across dozens of GPUs, giving them unparalleled access to data. In the top-tier P6e instances, this shared memory domain now spans an incredible 72 GPU sockets. That is effectively 144 individual GPU devices within a single rack, all acting as one unified compute unit. AWS is even liquid cooling these specific systems, which allows them to overclock the B200 GPUs by an impressive 11%, squeezing out even more raw performance for demanding AI workloads. Now, you might wonder about the practicalities. AWS sells these UltraServers through what they call EC2 capacity blocks. This simply means you can reserve these pre-configured clusters in chunks, from a single instance up to 64 racks, for terms up to 6 months. It is like buying a large block of premium compute time, tailored for massive AI projects. But what about the cost? This is where it gets fascinating. We have seen a lot of analysis comparing the price performance of these new Blackwell instances against previous generations, like Nvidia's Hopper H100 and H200, and even older Ampere A100 GPUs. The numbers tell a compelling story. When we consider the flagship, liquid-cooled P6e instance with its 72 Blackwell B200 GPUs, it costs about $9.14 per teraflop for a 90-day rental at FP16 precision. Surprisingly, this monster machine only carries about a 17% price premium in terms of performance compared to the slightly less dense, air-cooled P6 B200 instances. Given the sheer density, power, and cooling requirements of the liquid-cooled system, that is a remarkably small premium. AWS really makes this advanced tech accessible. And speaking of accessible tech, the narrative around AI performance is rapidly shifting. We are moving beyond just shrinking transistors. The new frontier is lower precision computing. If you can train your AI model using FP8 or even FP4 precision, the costs per teraflop plummet. With Blackwell chips, leveraging FP4 can effectively cut your cost per teraflop in half, and then in half again. This means you can either rent 1/4 of the machinery to get the same work done, or you can spend the same money and train a model 4 times larger. That's a massive leap in efficiency. Now, here is a twist. AWS has its own AI accelerators, the Trainium chips. While their first generation, Trainium 1, required twice as many units to just barely beat Nvidia's A100, the new Trainium 2 changes the game. Trainium 2 delivers a 3.5 times increase in FP16 performance, and an incredible 6.8 times boost in FP8 performance compared to its predecessor. And here is the kicker. At FP8 precision, the Trainium 2 costs a mere $3.72 per teraflop. That is less than what AWS charges for the Blackwell B200 nodes in either the P6 or the P6e instances. So if your AI model can leverage FP8, Trainium 2 becomes a serious dark horse, offering superior bang for your buck. However, Nvidia still holds the lead if your applications can run effectively at the even lower FP4 resolution. Finally, a word on older hardware. If you are still relying on legacy GPUs like the K40, V100, or A100, especially for on-demand rentals, the economic reality is stark. While they may have a lower upfront cost, their cost per teraflop is frankly terrible compared to these new Blackwells, particularly when you factor in the efficiency of FP4 mode. Clearly, if you need to rent instances on demand, you really want to be on the Blackwells, pushing them into FP4 mode. This shift towards lower precision computing from FP16 down to FP8 and FP4 fundamentally redefines how we think about Moore's law in the age of AI. It is not just about making transistors smaller anymore. It is about smarter computations. What new, unimaginable AI capabilities will we unlock now that this level of supercomputing power is just a few clicks away? We want to hear your thoughts on these new developments. Do you think AWS and Nvidia are setting a new standard for cloud AI? Let us know in the comments, and remember to subscribe for more deep dives into the tech reshaping our world.